Good morning, everybody, or good evening, or good afternoon, wherever you are. I welcome you to this second set of presentations introducing the new forecast system of the European Centre for Medium-Range Weather Forecasts. I am Florian Pappenberger, Director of Forecast, and it is my great pleasure to present to you today the new products and the latest verification results of our new system called 46R1 on behalf of the staff of the European Weather Centre as well as our Director General, Florian. With this presentation, I hope to convince you that we have a truly exciting and really excellent cycle and really brilliant scores with a massive amount of skill gain. For this achievement, of course, I don't have to only thank our staff and our many collaborators, but also our cooperating member states who have been, in particular the National Hydrometeorological Services, have been continuing to offer us strong support. I do believe our new forecast cycle demonstrates the strength of a common goal embedded in European cooperation at its best. Just to make clear what I'm going to say today, not everything is going to be actually I'm not going to be able to present everything. It's important to know that all information which I present is actually published on this website. Don't worry if you can't type down the link fast enough. This presentation will be available later, and you can also look for the link on the website or on our social media. This page, as I said already, contains far more information than can I physically present within 45 minutes. I think some of the information is actually quite technical and is extremely important to you when you use ECMWF forecasts. For example, on there we have things like changes to grip encoding, which may be particularly relevant if you use that particular grip file. On that page, you have recommendations how you actually retrieve parameters in an unambiguous way, that you actually get information you're asking for rather than some other random field. So I really urge you to go to this website and either watch the website, which you see on the left-hand side, click on the I, which is set to German, beobachten, or join the mailing list to get the latest updates of our forecast cycle. Just to start off, getting into the real meat of this, the new IFS forecast cycle has set 46R1. I can confirm that the release candidate has started, or is starting today on the 15th of May. From there on, there will be no changes anymore which alter the model results. The implementation cycle of the new cycle can be confirmed for the 11th of June, 12 UTC. And a full set of products will be offered until the operational implementation of the new cycle. At this stage, test data sets can be downloaded, you can acquire longer time series. The test data are now also going to be available in dissemination, and the test products are generated on a daily basis, just shortly behind after the current forecasting system, allowing you to implement and test your forecasting chains with that new system. All the graphical displays will be soon available through Easy Charts. And many of the slides which I'm showing today, the information will actually be updated on the website later this week. My presentation is very simple in terms of outline. I'm going to present you with the latest scores, the latest skills. I'm going to present you why I believe this is an exciting cycle. And that will be followed by the many new products which we have developed for you, the many new products which you asked for, the many new products which I believe have great value to you. But let's just go ahead and start with the different scores. Just to draw back a bit before I do that, there was actually a presentation already earlier about the science, and just to remind you that this presentation is available online. You can actually look at what was the latest news and the latest science in this cycle. You can see that we introduced a new continuous data assimilation, for example. We had a 1 hourly radiation update frequency for the ensemble, just to mention 2 highlights. You just can, again, go to the website which I mentioned before. You can click on a link there and you can watch the recording which shows Andy Brown, the Director of Research, presenting you with these latest results. Let's go to the scores. Of course, we always run scores already earlier, but now we come to the time where we actually have a long enough time series to make statistical relevant comments. This is what we call the scorecard. On the top right corner, you see again the website. These scorecards will appear on the website roughly later this week, and they're interactively, so you can click on them. On the scorecard, you see verification against analysis in the top rows and against observations in the bottom rows, which is dark gray and the top is light gray. Each row represents a parameter, and each column, or each two columns, represent an area, a geographic area of the globe. And then you have two different scores displayed for each of them. A root mean squared error and a CRPS. Blue means better and red means worse. The result is roughly based on 240 model runs, verification against analysis, and roughly 290 model runs, verification against observations. Of course, the more forecasts we produce, the more we will update this website. Currently, the period is roughly covering, the verification period is roughly summer 2017, winter 2017-18, and winter and spring 2018 and 19. This is actually a remarkable scorecard. If you look at the scorecard, it's mainly blue. This is unique for us, and this is very exciting because it's so good compared to our usual cycles. We have a few deteriorations, which are the droppings. If you look at the improvements, oops, why is it not going? If you look at the improvements, they are actually between 0.5 and 4% for most parameters and levels and forecast lead times. You don't have to believe my word. You can go to the website later and you can actually look at them yourself. If you look at the tropics, I think it's important to say there are some main deterioration in the tropics in the order of 0.5 to 1%. The deterioration in the tropics come from anticyclonic areas such as the South Atlantic and South Pacific, and they are due to a slight warming in the analysis and the introduction of 3D aerosol climatology. I will show you later also some scores for the high resolution, and it has to be said that the ensemble score deterioration in tropics is a bit more pronounced in high resolution because we also have a reduction of spread, which comes through changes to convection scheme, which create a slightly more stable atmosphere, but has slightly negative impact on the scores. Having said that, it is a remarkable scorecard. It's extremely blue, and I'm going to show you now 3 different examples of the scorecard, where I said you can click on later in the week and convince yourself of all the other examples. Let's start with something which is very common for us, an ensemble headline score for 280-50 hectopascal continuous rank probability score. Here you see the continuous rank probability skill score for 850 hectopascal temperature reaching 35%. So on the left-hand side, you've got a day at which this is reached. On the bottom, you have a time series starting from roughly 1998 to today. The blue curve is a 3-monthly average, whilst the red curve is a 12-monthly running mean. And if you look at the improvement, 45R1 is the current operational cycle, 46R1 is the new operational cycle. We have roughly an improvement of 4 to 5 hours in this particular headline score. So the bottom bar of the thing on the right hand side compared to the top bar. This is well and good. ECMWF has recently been challenged to look at more extreme errors, look at errors which really influence or which are large enough and which we would like to reduce. One of the scores we are looking for is a 2-meter temperature error. That's basically a score which evaluates how wrong we are, how many errors, how big is the fraction of errors in 2-meter temperature against observations. We've chosen a threshold of 5 Kelvin, and it's basically how often does the CRPS go above 5 Kelvin. Look at this graph. The ensemble forecasting system for 2-meter temperature, I've chosen day 5 here. It's the large errors that I just explained. On the y-axis, you've got the fraction, so you're starting of roughly 0.07 in 2005, 2004-ish, and you're ending up at roughly 0.05 in 2018 and 19. For your comparison, I've also plotted 3 other major forecasting centers, NCEP, the UK Met Office, and JMA, the Japanese. Here the improvement, so the score is negatively orientated, so the lower the better. Again, if you look at the right-hand side, you can see comparison between 45R1 now and 46R1 where we're estimating the improvement, and it's roughly 4%, which is quite a dramatic improvement if you look at the curve itself. It's significant in comparison to what we have seen before. Last but not least, we've done the upper air, we've done a surface variable. Let's go to a wave parameter. Significant wave height, for example, is an interesting one because, of course, we also changed in this particular the wave model. And if you look here, the ensemble significant wave height verification against boys. On the left-hand side, you've got the continuous rank probability score. 4501, so the blue curve, which is on top of it, is the current model cycle. 4601, which is the red curve, which is the new model cycle to be released next month, is about 6 to 8 hours gain in the medium range. On the right-hand side, we've plotted the CRPS relative differences between these two, so you can look at the normalized differences. The y-axis shows you the different lead times from 24 to 360 hours. And you can see from this plot on the right-hand side that the skill score improvements are significant. And they are significant for a very, very long time into the future. So we can at least say to 2064, maybe that's about it, but that's a significant improvement. The substantial improvement in wave parameters is due to a new wave model and is also linked directly to new wave outputs, which we're going to produce for you and put out for you. Again, I'm not going to go into the details of explaining you what exactly has been done. Either you go to the website, there's a detailed scientific explanation, including a memo exactly detailing what we have done and how we've done it, or you scroll fast through Andy's presentation and go to the right spot and have a look what he said about it. So far so good, that was the ensemble system. Let's move on. Let's move to the high resolution. Exactly the same concept. We've got an ensemble scorecard. Again, the different lines for different parameters. On the top in the light gray, if you look at the light gray on the left-hand side, that's against analysis. Dark gray is against observations. You can see different regions, a bit more regions in this particular plot. Again, for two different types of scores. Blue again means better, red means worse. We see in general a very similar signal, which is basically that the scorecard is mainly blue, so it's mainly improvements, with some deterioration in tropics. And as I mentioned earlier, if you remember the ensemble card, you could see or could remember now that it did have a slightly more reddish color in the tropics, and that was the decreased red. If you go to the different scores, we can actually see a 1 to 5% improvement for most parameters levels in forecast lead times. I give you this range because I do think you really need to look for yourself in the end. What is the parameter, which values which you find important, the parameters which you really care about, and click on them and judge for yourself. There's tremendous improvements in the wave forecast. If you look at that, it's about 5 to 10%, which is absolutely is huge. The deterioration in tropics should not be neglected. It's 0.5 to 1%. I've already explained where it comes from. Similar to before, let's just look at a single headline score. In this particular case, we're looking at a high resolution headline score for Z500 anomaly. I have to say that this scorecard is based on about 610 model runs, so slightly more the ensemble, so it's slightly more runs than the ensemble, so it's statistically a bit more significant. And this is the plot for it, so anomaly correlation of 500 hectopascal shear potential reaching 85%. On the y-axis, again, you've got the day when it's reached. On the x-axis, you've got different years and dates. You have different centers plotted for ECMWF. ECMWF, the solid line is the current model. The ECMWF, the red dashed line, is the era 5. And then there's an incorrect era 5 on this plot, which is the 46R1 estimated one. So if you look at this curve, it's actually quite a significant jump from the 46R1 estimated to the current curve. Indeed, it's approximately 2 hours gain in lead time, which is a significant gain in lead time. And you can see quite neatly it jumps above it and gives us a significant increase in skill. There's many other results which I could show you for this, many other verification results I could show you, and you will all find them on the website. For example, in the extended range, we have significant improvements in week 1 to 2 in the extratropics, up to week 4 for several parameters, due to the initialization of the reforecast for the era 5. One also has to mention that for tropical cyclones, the performance is neutral. There's a hint of improvement in the chuck, consistent with the improvements in tropical winds, but it's only borderline statistically significant. Hence, I haven't shown you the plots here, but you will find them on the website later. So far, so good in terms of performance. Performance is great, but of course, we also had a large number of requests for new products and new outputs. I just have to mention again that all these new parameters are expected to be added to the catalog of real-time products, pending approval from our advisory committee on data policy. The new parameters can be obtained through dissemination, ECMWF dissemination, but only after we've implemented the cycle and not in the test phase. However, you already have access to the new parameters, and they're currently available for testing in the Mars archive for downloading. So you can access them, but you can't have them through dissemination. And there's a fairly substantive list. If you want to go through the entire list and look at each single parameters, they contain simple descriptions, hopefully too, and they contain what the crib edition is, what components it is. I'm going to show a few of them, and you can really look at them on the website and look at the list. Let's just go to the first one. The first one was one which was requested for quite a while by quite a number of our users. It's 200-meter wind. It has main relevance for the wind energy. It will be available in Crib Edition 1. It's the U and V component, and it will be available in high-res and ensemble. I already said something about ocean waves. There's a large number of ocean wave parameters available. It all goes from wave induced and mean sea level correction to number of events in freak wave statistics to wave turbulent energy fluxes into the ocean. All these parameters are available in Crib 1, and these parameters are available in the high-res wave model, in the ensemble wave model, and in the high-res, high-resolution standalone wave model. A small word of warning here. ECMWF plans to discontinue the high-res standalone wave model, and users and customers will be contacted shortly in asking whether they couldn't switch to the high-resolution wave model, which is coupled to the atmosphere and therefore has significant advantages. Let's just look at a nice example of this. This is ocean wind waves. This is the height of the largest single wave in meters during an incident involving the cruise ship Viking Sky, 23rd of March. What you see there is a forecast going through, and the more reddish the color is, the higher is the maximum individual wave height, and it's north or on the west coast of Norway, and you can see quite neatly how it hits the coast and goes through it. This was really only possible through the recent development in science behind nonlinear waves. The wave interaction yielded improved characterization of the tail of the wave heights distribution. I think it's a nice illustration of a new product which is available through the catalog, which is available currently at ECMWF. We have more than that. We've got ocean parameters available, requested for quite a while. They're produced by the NEMO model. We've got in there sea ice thickness, mixed layer depth, seawater practical salinity, and average potential temperature in the upper 300 meters. Similar to the other parameters, these parameters are available in Crib 1 edition. They're available for high-res and ensemble, and they're interpolated to 0.25 degrees, so they interpolate the resolution how the ECMWF model sees them and uses them. I think this is important. They're not on the original resolution of the NEMO ocean wave model. Have a quick look at a nice example, which doesn't play. It doesn't play. That's disappointing. Which unfortunately doesn't play. It does play on my PowerPoint. It doesn't play in Adobe Connect, unfortunately. What you would see is a really nice animation of the 300 ocean temperature from 4601 during the tropical cyclone Fanny, and you would quite neatly see how the tropical cyclone hits the coast, and at the same time you're seeing colors underneath the ocean temperature. Can I make it work? Probably not. Can't make it work. These web slides will be available on the web, and you can look at it yourself and enjoy the colors and enjoy the interaction with the temperature. Sergio is playing at the same time. In addition, something which was requested for quite a while is parameter and potential volatility levels 1.5 and 2. You can see quite a number of parameters here. Again, they're all in CRIP edition 1. Parameters are available in high-resolution ensemble. It's really geopotential, pressure, specific community, U and V component. They will be available to you already, and you can look at them already on the Mars archive. ECMWF has become the World Meteorological Center. As part of the World Meteorological Center, there have been certain obligations and requests to introduce new type of event probabilities, and this is the set of event probabilities will be available as part of ECMWF's role as World Meteorological Center. There are simple things like total precipitation of at least 25, 50, and 100 millimeter in terms of threshold. There's 10 meter wind gusts, there's probability of 850 hectopascal, probability of 800 in terms of standard deviation, but also in terms of anomaly. On the bottom right, you actually see a picture of that, as you can see it on the web. I think there's something which is quite important to know. Of course, these parameters are all ensembles, as you can probably see from the description. All these parameters are available in CRIP 2 and not CRIP 1 as the previous ones. However, we really believe this shouldn't matter to you, because you actually use the EC codes version, which is on the website, to decode these particular CRIP files, so EC codes version 2.12.5. Then you wouldn't actually experience any difference. You can actually do a smooth conversion between CRIP 1 and CRIP 2, and for user, it doesn't really make any difference. This was one set of post-processed parameters. The second set of post-processed or derived parameters is the extreme forecast index, or shift of tails, or the two of them. And here we have really introduced three fundamentally different ones. One is for water vapor flux, and I'm going to come back to that in a second. But there's also now an EFI and SOT for weekly mean temperature and for 1 week total precipitation. The water vapor flux, I believe, is actually quite an interesting one. The water vapor flux is the magnitude of the combined vertical integrals of the eastward and northward water vapor flux component. And the EFI really is aimed to complement the precipitation EFI by highlighting large areas or large-scale water vapor transports in the atmosphere. They're available for exactly the time standard as the precipitation, so daily up to 7 days forecast, and 3-day averages up to 10 days, and then 5-day average from there on. And the reason why I believe they're so interesting, so important, is actually shown in this picture. This picture shows an example of the heavy precipitation that hit California in February 2019, you may remember, and was caused by a powerful, huge atmospheric river bringing air abundant in moisture from the Pacific, really, towards North America. And you can quite neatly see this 5-day forecast on the left-hand side. I haven't shown you the precipitation forecast at the same time, but the total it really indicates that this feature is coming and it could cause severe downpour. The total precipitation EFI also provides a hint of this large accumulation of rain, obviously. But I think we have shown through scientific literature or through scientific studies that the water vapor flux EFI currently does give you a sort of a little bit of earlier heads up and warning. There's one other thing which I ask you to watch out for. ECMWF has changed its climatology and has changed very often many of its fundamental computations from era interim to era 5. The era 5 data were now released. They're going back to 1979. They're available for free download through the Copernicus Climate Data Store. And we started to utilize them now consistently throughout our forecast chain. For example, in cycle 4601, era 5 data are now used to initialize reforecast. And I also use the era 5 EDA to perturb the reforecast initial conditions. In addition, the climatology for the EFI and the SOT have been replaced from era interim to era 5. And I think this is actually quite important. If you remember, era interim was a really good reanalysis, but of course it has been based on a very old model cycle now. So there were inconsistencies between the current model cycle and the previous model cycle. Era 5 is much closer to our current model cycle. And you could see this, for example, in persistent high EFI values, which we have in some regions, for example, over East Africa, which were probably due to the large inconsistency between the climate the climate derived from error interim and the ensemble forecast. Whereas the error 5 actually then removes the signal and makes it far more believable. And you can see this in these two different plots. I've circled you the two areas. You've got the error on the right-hand side, you have the old climatology. In both cases, we used 46R1 not to confuse the different cycles, so the new cycle. And you can see there's standing areas of high EFI values in red, whereas on the left-hand side, this has been far more subdued. We believe this is now more close to reality, and we also now believe this is closer to what it should be. And therefore, error 5 should, or the inclusion of error 5, should bring significant improvements in the forecast and the prediction of the EFI. And I've attached here, which is not directly related to the cycle, but I've attached here a word of warning. For any of you who still use error interim, I just would like to note and make sure that you understand error interim is being phased out, and users are strongly advised now to migrate to error 5. The last date which will be made available in error interim is on the 31st of August. Of course, error interim is not real time, so this publication will roughly happen in September. So I really urge you now to move away from error interim and move to error 5, so you don't get to August and then suddenly realize you're missing data. Error 5 is a superior model, a superior analysis, and is available, as I said, for free download through the Copernicus Climate Data Store. This is really what I wanted to present to you in half an hour. The key points is implementation date is the 11th of June. There's a significant and large number of new products, and I hope you like them. We are waiting for your feedback. We have actually in a couple of weeks, we have the Using ECMWF meeting, the user forum, and I'm really looking forward to welcome you here and providing your feedback to ECMWF and us to improve our products even better. The improvements are between 0.5 and 4% for most parameters, levels, forecasts, and lead times. I'm deliberately quoting here the ensemble. And there are some deterioration in the topics, which I already explained why they're happening. Just to stress again and to make clear, more information is available on the website. We have a dedicated website which you can watch and a mailing list you can follow. If you have any questions which either can't be answered there or you don't want to leave us a comment there, you can reach us under support at ECMWF and ask more questions. And that concludes my presentation. Thank you for listening.
Questions now?
Yeah, please, questions. If we actually go back to this, so Alejandro is asking, have you made any verification of wind speed in the levels closest to the surface? We do have verification against wind observations. I'm just trying to go back to one of the scorecards. Excuse me for being a bit slow. And you can actually see in here, there's a, let's go to the ensemble. You can actually see here, there's a line for 10-meter wind speed. And you can see there's significant, or there are improvements in the wind speed, so you can look at them. So we have made verifications to the surface, and they have improved. I can't tell you now from memory how many % they have improved, unfortunately. I would have to, unfortunately it's not interactive, so I can't click on the plot to show you. I think by the end of the week, these scorecards will be available. And then you can click on the wind speed yourself and have a look whether it is the improvement you were roughly expecting or hoping for. Thank you for the question. Name's typing. Can you say to what extent roughly convection will be affected? Convective precipitation. I have to admit I can't exactly remember from memory. So the question is, can you say to what extent roughly convective precipitation will be affected? I will have to come back to you on that one because I cannot remember what exactly in terms of scores it meant in terms of thing. It is clear that we did changes to the convective scheme, which did create a slightly more stable atmosphere. I have to come back to you for details. Maybe just post the answer on the website afterwards. Sorry for not being able to give you more direct. Oh, maybe Thomas can give you an answer. He's typing at the same time. Thomas has the interactive graph and he's just responding to Alejandro's question, which is 10 meter wind speed has improved by 0.5% roughly in Osombo and High-res. Okay. Thank you very much for listening. Thank you very much for attending this webinar. And we've got somebody else typing. Sergio. That's Andrea. If you have any more questions, please don't hesitate to simply send us an email or make a note on the website. We are more than happy to answer more questions. And we hope you enjoy the news cycle as much as I do. And you all join us in celebration on the 11th of June with some chocolate. Thank you very much.